So we'll start off with the clouds for your little angle cheat sheet. So a right angle. What is a right angle? It is a 90-degree angle. So here's what we're going to do. We're going to draw a little 90-degree angle. So by definition, we'll label it 1. By definition, the measure of angle 1 equals 90 degrees. Okay? By definition, a right angle, that measure equals 90. Okay? What about an obtuse angle? What do we know about an obtuse angle? It's more than 90. So something that looks more like this. All right? So we'll call that angle 1 again. So this time, the measure of angle 1 is greater than 90 degrees. Not 9 degrees, 90 degrees. Cool. What about an acute angle? What do you know about them? Yeah, it's less than 90. So here we go. Let me zoom in so I can draw it a little cleaner. Well, again, we'll call it 1. So the measure of angle 1 is less than 90 degrees. And greater than 0 is actually also true, because you can have negative measurements, negative angle measurements, but we're not going to talk about that in geometry at all. We'll leave that to pre-cal. Okay. What about a straight angle? What do we know about a straight angle? What do those measure? They're 180. All right. It's essentially a line. There are times when it is beneficial, so we'll label this one angle 1. Wow, that's a horrible angle sign. So the measure of angle 1 is 180 degrees. And it's called a straight angle because it's a straight line. Okay? Of course, that's one that you know, but you may not have thought about in those terms. Okay? Any questions so far? All right, let's keep rolling. I want to burn through this page pretty quick. Adjacent angles. Okay, what do we know about adjacent angles? What do you think they are? Okay, let's put it this way. If I am adjacent to Riley, we are what? Essentially touching each other, not next to each other, right? Sorry, Riley, I apologize about that. But we're next to each other. Things that are adjacent to, like books on a bookshelf, are adjacent to each other. Adjacent angles are angles that touch each other, like that. They share a side, they share a ray. Okay? So, call that 1, call that 2. We'll say angle 1 and angle 2 are adjacent if they share a side. Okay, if they share a side, or if they share a ray, and by ray, I mean this thing right here. It starts right there and goes whoop. Again, you got to make the sound effects. Cool? All right, give me a second. Right. Let's keep on rolling. Again, all right, so complementary angles. This is one you probably already know. If I tell that two angles are complementary, what do we know about them? They add up to 90. If I have two angles that are complementary, their measures add up to 90 degrees. They don't have to be equal. They can be very different. Like those two angles are obviously not equal, but when I add them together, we'll call this one 1 and this one 2. So the measure of angle 1, oh, stop moving on me. Angle 1, nope, not and, plus the measure of angle 2 equals 90 degrees. Cool? And complementary is 90. Supplementary, what do you think supplementary is? It's 180, okay? So complementary go to a right angle. Supplementary go to a straight angle. So that's the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Not squared, degrees. Whatever. There we are. And I'll pause for a minute because we're kind of going quick. Any questions so far? All right. We're just kind of laying down the ground rules so that we're all on the same page, and then we'll start applying them here in a few minutes. A linear pair. We put a linear pair right there because a linear pair are essentially, they're supplementary. Supplementary. They are two angles, that add up to that make a straight angle. So in this case, angle 1 and angle 2 are not straight angle, are a linear pair. Okay, because basically that pair of angles makes a line overall. Okay, it's two ways of talking about the same thing. There is a subtle difference between the two, but we're not really going to explore that. Just understand those are two ways of saying the same thing. Okay, so that term might be new to you, but the concept is not. Vertical angles. This one might be new to you. I don't know. We'll see. If you have two lines that cross each other, those are obviously two lines. Okay? The opposite angle, so like this angle and that angle, angle 1 and 2, are congruent. They are the same. So angle 1 is congruent. I'll say the measure of angle 1 is congruent to the measure. No, I don't want measure. I just want angle 1 is congruent to angle 2. Okay? So if I know that, well, what can we say about angle 3 and 4? They're also congruent, exactly. Anytime you have two lines like that, they're the opposite angles. They're called vertical angles. They are congruent. So angle 3 and 4, angle 3 is congruent. Wow, my thing does not want to make the congruent sign. Yeah, I know, my handwriting's just that bad. Cool. So that might be the first new thing for a lot of us. That just came from in the class we just talked about it. Let's keep rolling. This next one. Yeah, this is brand new. You haven't done this in 3 weeks. An angle bisector. No, we've done this many times. An angle bisector, just to kind of have everything down. An angle bisector does what? It cuts the angle in what exactly? In half. It directly cuts it in half. So basically, that side is the same as that side. Okay? So if I said 1 and 2, angle 1 is congruent to angle 2. All right? Fair enough. So we're going to be talking about angle bisectors, we're going to have vertical angles. We'll talk a lot about this sort of stuff today. But the last one. This one kind of tags on to what we did yesterday. So I'm going to scratch up here and do a little scratch work. Don't write this down. Remember on, Monday? We said if we take this segment and add it to that segment, it equals the whole segment. Remember that? Well, we can say the same thing about angles. If I take, given two angles, I'm going to call them this angle 1, this angle 2, and I'll call the whole thing angle A. Wow, what did I just write there? Angle A. Basically what I'm going to say is if I take the measure of angle 1 plus the measure of angle 2 will equal what? The measure of angle A. Exactly. No, you're absolutely right. The measure of angle A. All right, this is just like the segment addition postulate. It's the angle addition postulate. If I have two angles, you add them together, you get the size of the overall angle, the bigger angle. Cool, so that's probably really the only new thing besides the vertical angles. Cool? And so this is your cheat sheet for pretty much today, as well as, I say for the test, but you're not going to get to use it on your test. But any questions on any of this? Is anybody still writing at all? Okay, so here's what I want you to do. Turn the page. This next one says, use the figure to the left and determine if the angle pairs are linear pairs, vertical angles, complementary, or neither. Remember, linear pairs are supplementary, the same idea. So for like number 1, it says number 1 and number 4. Those are what? Are they linear, vertical, complementary, or neither? They're linear pairs. They make up a 180-degree line. A 180-degree angle, I'm sorry. So if you put linear pairs or supplementary, it doesn't matter to me. Linear pairs. Does that make sense what we're doing? All right, take, I don't know, 2 minutes. Knock out the other 7 if you haven't already. All right, if you got 1 more, 2 more to go, that's fine. Go ahead and finish up. But let's talk about these real quick. So like number 5 and number 1. So right here, 5 and 1. They're across from each other, so they must be what? They're vertical angles. Good. Vertical angles. Vertical angels. What about number 1 and 3? So that's this guy and that guy. Well, do they add up to 180 degrees? No, you would need the 2 to do that as well. Do they add up to 90 degrees? No, so, and they're not opposite each other, so they must be neither, or neither. Neither or neither, however you want to say that. Okay, so 1 and 3, they're none of what we've described. There is a way to talk about those angles, but it's nothing we've described so far. All right, 8 and 9. Okay, that would be these 2 down here. Those are what? They're supplementary or linear pairs. Either way, I'll write supplementary this time, just because I need to remember how to spell it. Supplementary. All right, 7 and 8. These 2 right here. They're vertical. Good. They're vertical angles. Vertical angles. What about 6 and 4? Yeah, this one and that one. There are ways of comparing those 2, but nothing that we've talked about. So, neither. All right, 2 and 3. These 2 up here. Good. They add up to that little 90-degree box they give you, so that's complementary. Complementary. And last but not least, 6 and 9. These ones. They're vertical angles. Okay, they are. There's 2 lines like this, and they're, well, let's put it like that, and they're across from each other. So they're vertical. Cool. Any questions, comments, complaints? Sweet. Pull out the next page if you haven't started it already. Where is it? This one. We're going to do the first one together just to kind of get you an idea of how to think through these. And then we're going to turn you loose to kind of do the rest of it kind of in groups, on your own, however you want to handle that, that's fine. But number 1. So the idea of this is just to kind of slowly work your way around it. Okay? So let's start here. 62. This is 62. Can you use that to find this one? How? Subtract it from 90. Good. This is a 90-degree angle, therefore they're complementary. So 60 minus 92 leaves us with what? 28. Does that make sense? All right. No, we know those have to add up to 90. Well, if this one is 90, what must this one right here be? It must also be 90 because they got to add it to 180. Okay, so this one's 90. You see where I'm going with this? Okay. How are we going to get to these 2? All right, maybe we'll say get to this one. Is there a way we can get to this angle right here? They're not quite supplementary because these 2 don't add up to 180, but this one and that one add up to 180. Good. 180 minus 62 will get me this big one. All right, so that's 180 minus 62. What does that give me? 118. So this big one is 118. Cool.
Wait, both K, N, and I?
Yeah, the angle from K to T to I. This angle right there is 118. Because 180 minus the 62 will leave me with that 118. All right, which, well, how do I go from that down to these ones? Well, why would divide by 2 work? Because it's a bisector. They're the same. They both have one tick mark. They both have the congruency, so we know they're the same. All right, so what's 118 divided by 2?
59.
59. All right, so now that we know this, let's go start answering the questions. So UTP, that's this one right here. We already figured that one out. That's what? 28. Okay. PTI. Well, that one's already given to us. You're right. That's this guy. That's 62. That was one of the givens. All right, UTO. Okay, that's this one. That's what? 90. Cool. So we went all the way around, so now we just have to answer the question. NTK. N, T, and K. So that's from here into the middle and then back out. So that's 59. Let me erase a little bit of my marks over here. ITK. So that's this one to the T. Oh, good. That was the 118 we found. And the OTN. So that's OTN. That's this big one. Yeah, just add 62 and 59.
What? Oh,
Yeah, just add these two together to get that bigger angle. It's what? 112, 111? Or is it 121? 121. I'm losing my mind. 121. Oh, and they're all degrees. So I can put my little degree signs up there. Cool. That's just a method of how to get around these, all right? So here's what I want you to do. Start working on the rest of them. Okay? Like the next one, you know, it says the bigger one is 134. So use the other two angles to get up to that 134.